Hi there. Welcome to Pilot Surgeons and Developers, how to improve your application security by using checklists. My name is Joe Camerly. I'm a product security engineer. And before we get started, I do want to set a disclaimer that this work is all my own personal work while I do security work for my employer. None of what I'm going to be talking about is relevant to them, nor have they endorsed this in any way, nor should anything I say be an endorsement of my current employer. Having said that, welcome to this talk. I know that we're doing this virtually and it's going to be a little bit odd. However, I am in the live chat alongside the playback of this. So at any time, if you have comments, suggestions, feedback that you'd like to offer, please feel free to drop it into the chat. I'll be happy to respond. Additionally, there is going to be a live session following this where we'll have much more ability to interact directly, collaborate on some of the ideas presented in this talk. I'd really love to have you stick around for that and to have a chance to interact with you much more personally. With that, we can go ahead and jump right into the talk. Scientists that study problems have classified them into three basic varieties. There are simple problems, there are complicated problems, and there are complex problems. Simple problems are pretty much what it says in the box, something like learning how to bake a cake from a recipe. You have a recipe, you follow the instructions, and once you learn it, you basically have a very high likelihood of success doing the same things and getting the same steps with the same results. Complicated problem is something that's more like sending a rocket to the moon. There's not a simple recipe for it. Often it requires multiple people collaborating, coordinating, teams with specialized experience. However, things like the laws of physics are pretty consistent, so that once you've learned how to send one rocket to the moon, you can usually repeat the process with similar rockets and expect similar results. Moving on to the complex problems, something that is defined as complex is like raising a child. Unlike rockets that are constructed to be virtually identical, each child is unique. And even more, the environment of any given child is different from any other environment. If you have children, you know that raising a child does provide some experience, but the lessons you learn from one child do not always directly apply to another one. Indeed, the techniques that you may have used for one child may be completely different, and you may be completely ineffective on their brother or sister. In that way, building software is defined as a complex activity. By definition, most software is bringing something into the world that wasn't previously there. This means that, like a child, there are some common similarities between software solutions, but there are also a number of unique circumstances. Building a secure application is also something that cannot be completely controlled by a simple set of steps, and it does require active participation by developers, as well as those that help to support the developers. Giving developers freedom to innovate while providing a usable method to remind them of what they know and what they need to do is the purpose of building our checklists. We'll start with some simple definitions. Just to make sure that we're all on the same page. A checklist is basically a set of simple, straightforward, easy to assess criteria. It should be well targeted, detailed enough for a user to assess if an item is completed, but also not get bogged down with unnecessarily overly complex details or items that are not relevant to their current task. There are two major types of checklists. The first is defined as do list, or more accurately called call do response. This is what most people commonly picture as a checklist completion process. In the do list method, the checklist drives the process. It's a step-by-step approach. The user works through the checklist, performing each action in series, and then recording the results. This method can reduce redundancy, as there's no need for follow-up process, since the required actions are usually taken during the execution of this style of checklist completion. One of the disadvantages is this method can lead to steps getting skipped or omitted in high distraction environments. It's very easy for a user to skip a step if the execution sequence is interrupted and not notice the omission until it's too late. While many of our environments are not as distraction prone as airline cockpits or operating theaters, I think that in some instances, such as building and releasing security fixes in response to an incident, perceived overhead of a do list process may feel like unnecessary overhead for the stakeholders. Second method of checklist completion is called challenge response. It's also better described as challenge verification response. In this method, we're using the checklist as a backup procedure. The user performs whatever actions they need to take. In our case, developers write code building software according to whatever processes and quality criteria you have in place. And then they use that checklist to verify that what they have done is in accordance and meets all of the checklist requirements. This challenge response pattern is the most commonly used pattern by major airlines as well as other high sensitivity environments. Now, one or both of these methods may not work for you specifically based on your culture, your environment, your requirements, and that's okay. The purpose of this talk is to give an overview of different methods, how they've been enacted in the real world, and to give you a starting point to take back and to build on. There's not a one-size-fits-all solution. Checklists have to take into account corporate culture, development methodologies, how your security teams work and interact with development teams, as well as your people's preferred work styles. Even in the airline industry, with identical equipment, each airline has their own preferred work style, and thus a unique set of checklists and styles that are suited for how that corporate culture works. It's also well within the scope of a checklist implementation to land on a hybrid solution, where some checklists are do lists and others are challenge response. We'll cover a little bit of what a checklist is now. As I've said, a checklist is not intended to be a comprehensive guide, nor should it replace a well-defined secure coding standard. Comprehensive security standards, detailed process documentation, and strong security controls are also essential. Without any of those, a checklist is essentially useless, as the purpose of a checklist is to be a memory aid and to cause the user to stop and think before acting. A good checklist will raise high-level awareness of risky situations and provide a limited set of options, but it's not going to cover all situations. Just as flight checklists rely on training and detailed operational procedures, application security checklists must also be backed up by good security training and written resources for developers to use. All the checklists in the world will not help someone who does not have the necessary background knowledge. Checklists must be usable. If something is too long or complicated, it won't get properly addressed. Human memory is fallible, and human attention to detail, especially when working on routine matters that are perceived as mundane, can cause items to be easily overlooked, especially in the midst of complicated activities, such as preparing to cut someone open, attempting to get 200,000 pounds of metal, fuel, and people to fly through the air, or building a system to allow customers to securely use their credit cards and purchase things over the internet. Good checklists must be precise. They must be relevant to the situation at hand and describe actions that are both meaningful and actionable to the user. They must be engaging for the user and work as a memory aid, not a rote list of steps that just have to be checked off in order to get to the next phase of your work. Just like agile development techniques, when you give the developers the leeway to innovate, a good checklist will empower those developers to build more secure solutions. In order to measure the effectiveness of our checklist, we need to be able to verify their effectiveness. Across multiple industries, aviation, medicine, and construction are some of the major industries with well-documented successes in using checklists to drive effectiveness. While we in the security industry are still evolving our methods of measurement, the effective use of checklists will raise communication, increase collaboration, and it should result in more secure systems moving forward. Can you absolutely measure a reduction in security incidents? That's a definite challenge. It depends on your organization's use cases and security maturity. This can be easier for some externally facing products with the product security process in place. With internally developed and managed systems, it's a lot more difficult to have that sort of absolute metrics. Either way, there is still some uncertainty involved, as a straight up reduction in the number of vulnerabilities may or may not be directly attributable to the use of checklists or any other individual activity. The aviation industry has been using checklists in various forms since at least 1935. In 1935, there was a new Boeing test bomber that was being prototyped and being tested. Initially, after a smooth takeoff on one of its first flights, it stalled, turned on one wing, crashed, and exploded. Killed 2 of the 5 members of the crew, including the pilot, who was also the chief of flight testing at the time. So it's arguable that it was not lack of pilot experience that caused this sort of crash. The investigation that occurred afterwards revealed that there was no mechanical issue. The crash was simply caused by, quote, pilot error. This airplane was more complex than most previous models, including having 4 engines to manage. At this point, the pilot had simply forgotten to release a single locking mechanism on the elevator and rudder controls. Newspapers at the time reported that the airline was probably too much airplane for one man to fly. Boeing nearly went bankrupt as a result of this when the Army Air Corps chose a Douglas airplane instead as their primary bomber choice. Luckily, the Air Corps did purchase a few of these planes to be used as test planes. It was a dedicated group of test pilots who were determined to prove that this airplane was flyable. One thing that they did, instead of mandating that there needed to be more training, because again, one of the pilots that crashed the original plane was the head of testing. He had been trained as much as anyone, if not anyone else in the area. So what they came up with was a set of checklists to cover takeoff, flight, landing, and taxiing. It was a basic list of things that the pilots already knew how to do, but that could easily be overlooked during complicated but routine setup for a flight. That checklist worked. It demonstrated that the airplane could in fact be flown successfully. This airplane became the B-17 bomber, and it ended up being the 3rd most produced bomber of all time. The aviation industry has used checklists for great effectiveness over the years. The chart on the left shows plane crashes by year, along with corresponding passenger and crew deaths. You can see that after the 1940s, even as the number of flights increased, the number of crashes decreased. The chart on the right shows a trend line of United States commercial flight hours since 2000, excluding this current past year as well. Over the last 18 years, the number of hours spent in flight continues to increase, and yet crashes are rare and noteworthy events. Similarly, in medicine, the use of surgical checklists has been increasing. The Checklist Manifesto by Atul Gawande, which is one of the inspirations for this talk, describes a process by which Dr. Gawande pioneered the concept of checklists in medicine. There have been studies that show consistent and repeatable improvement in surgical outcomes in locations where checklists are used. The use of checklists provides noticeable and measurable improvements, regardless of the resources available to the testing hospital. These studies have spanned a range of institutions, from some of the top-tier institutions in some of the wealthiest countries in the world to underfunded, crowded hospitals in developing economies. The use of checklists has resulted in improvements across the board. This is an example of the World Health Organization surgical checklist. Some things to note are the simplicity of design, the questions that have clear and meaningful answers, and the categorization to help people focus on the items that are most relevant to them at any particular phase. Also note that the checklist calls out that it is not a comprehensive resource, and that customizations by those who use the checklist are actively encouraged. Collaboration and a feeling of ownership are important factors in the successful implementation of a checklist program. I believe that the use of checklists in development and application security can provide meaningful security benefits in the posture of our applications. We're now going to move on to the nuts and bolts of how we can start building a checklist for our organization. There are a number of items that we're going to cover. We'll define the ground rules and objectives for our checklist. We'll define multiple checklists, as no single checklist should ever cover everything. We'll then cover the basic questions that are likely to apply to many different areas, and also some situational questions that are more specific. Again, I want to remind you that the chat window is there for your use. If you have any questions, feedback, please feel free to put them in there. I'm happy to answer them as we go on through this discussion, and there'll be some time at the end as well. The main idea that I want to get across is that building a checklist is a collaborative process. A checklist cannot be another set of processes that we inflict on the development teams. A primary purpose and value of checklists is that they contain a collaboration between security knowledge and development processes. They must be built by direct involvement and open to changes coming from our consumers, the developers. We'll start our ground rules by building an effective checklist from the aviation and medical world, where our checklists have been shown to work well. Our ground rules will guide us, and as noted in the previous slide, our intention is to increase communication and collaboration. Our checklists are going to serve a dual purpose. Their explicit purpose is, of course, going to ensure that rote tasks are consistently implemented, that the developer's execution and ongoing reevaluation of the checklist also serves as an important communication bridge between the developers and us security professionals who are supporting them. We'll take some lessons from surgery, where taking time for everyone on a team to introduce themselves and their roles results in better patient outcomes, and we'll apply that to application security. If the developers know who their security people are and understand that the goals we're aiming for, then there can be a larger sense of teamwork and a willingness to stop and ask about things rather than just plowing ahead with development. Let's take a moment to review this block of text describing what the aviation studies believe their checklist should achieve. I'm not going to read through the whole slide, and you can feel free to come back to this later. But essentially, we're going to boil it down as checklists must be standardized to a certain extent and have to at least be consistent. They should serve as an aid to memory and a backup for our processes. The process of working through a checklist should be logically ordered, and a checklist should provide a framework for both the intra-team and cross-team communication and collaboration. Our checklist should be designed to allow for any team member, regardless of role, seniority, or technical skills, to detect and call out anomalous items. Nobody can know or see everything. Sometimes detecting a potential vulnerability can come from an unexpected quarter, such as, say, a project manager who becomes more aware of data privacy standards by being exposed to the concept on a checklist. This can really help those who are new to the team, those who are lesser experienced developers, those who may not have primary development roles, to be empowered to notice and call out some vulnerabilities. Essentially like in an operating room where there is a checklist and where there's this team introduction and comfortability with the members of the team, non-surgeons in general can feel more comfortable in noticing, calling out potentially risky situations. This is something that I think would greatly benefit in being translated to the application security realm and have that level of trust among the development teams with the security teams. Finally, the teams that use checklists must have a sense of buy-in and ownership. Those teams need to feel that the checklist items are relevant, that they can be effectively executed and evaluated, and they also have to understand and be committed to the purpose behind each of the items on the checklist. Any irrelevant or ineffective items on a checklist can lead to minimization of use or even outright disregard of the checklist. This can give us yet another failed security initiative and even more exposed vulnerabilities. In aviation, they don't have a single checklist, and neither should we in application security. Just as there are different checklists for different phases of flight, pre-flight, takeoff, standard flight, and landing, as well as checklists designed for emergency situations, we should also have a number of checklists that are appropriate for various scenarios. The cognitive redundancy provided by checklists can be a benefit in all phases of our application security development lifecycle. Checklists should cover our standard operating procedures and should be able to be used by developers as they go about their day-to-day business, designing, writing, testing, and deploying code. Just as airline pilots use their checklists to ensure that they do not forget to enable critical settings during flight, developers should use our checklist to have a reference to remind them of how to build secure code. Straight and level flight still requires monitoring and adjustment. Standard development processes can integrate checklists into their workflow with minimal disruption. There are also those more complicated scenarios that require more specialized knowledge. These scenarios can also benefit from checklists. Development of high-risk components for authentication, cryptography, or any other high-risk areas should either have specific steps or even entire checklists for covering their specific scenario. Checklists can also be used to effectively respond in emergency situations. When there are mechanical issues with an airplane, there are numerous troubleshooting checklists that the pilots can work from. Similarly, we can build checklists for incident response, breach disclosure, and other high-risk, high-pressure scenarios. Having an agreed-upon set of steps that have been thought out ahead of time and shared across an organization can help prevent missteps and mistakes in the heat of the moment. Our checklist shouldn't be something that we impose on developers from a security group. Collaboration is essential. It provides both a sense of ownership over the process, as well as the feelings that to ensure that the items are relevant and can all provide the expected results. One of the benefits of checklists is not just from going through the items. A major benefit is improvement in communication. Surgical teams that know each other, even just through a quick introduction of names and titles just before a surgery, are more effective and have a better patient outcome. This effectiveness is driven by communication. When you have names to put with faces, it humanizes everyone in the group. It increases a sense of ownership and makes people feel more comfortable with calling out those potential issues. Checklists are not a one-size-fits-all solution. Checklists need to be customized to fit your corporate culture, your development processes, your tooling checklists, choices, and to meet the needs of the software you're building. In order to build a good checklist, you're going to have to collaborate. You're going to have to collaborate with lots of non-security people and let's talk about some good ways to do just that. We'll start with the major consumers of our checklist, the developers. They need to feel both encouraged to use them as well as empowered to change them as necessary. There's usually a bit of a tension between security groups and developers. We all know that the most secure system is one that's completely isolated and does nothing. Developers, on the other hand, have different incentives. They get paid based on how many potential security vulnerabilities, actual features that they can expose to the world. When building checklists with developers, we should work with them so that we understand how they understand how every item on a checklist helps their systems to be more reliable, more available, and more stable. Just saying, it's more secure to do X is usually not a winning strategy for collaboration. Having checklists that span multiple groups and include operations teams can also help with both day-to-day operations as well as incident response. Risk comes from everywhere. Maintaining good communication with people, keeping our systems running day in and day out can be very beneficial. Checklists are also facilitate knowledge of people and roles across groups. Again, leads to increased communication, increased improvements in things such as incident response where there is essential cross-team collaboration. Using checklists also provides more effective communication openings between different security groups. Good working relationships with infrastructure security, enterprise security, risk management, and other security-centric teams is enhanced by the knowledge that there is a commonly known playbook for everyone to use based upon these checklists. We even need to collaborate with management. As the ones who set priorities and sign the paychecks. Management needs to have an understanding of their power to cause essential security processes to be circumvented. Management should have an understanding of how performing security-related work can be a benefit. The benefits of a more secure code base can be expressed in ways that management understands. What's one of the things that management best understands? Cold hard cash. If we can demonstrate that more secure systems are more reliable, and the more reliable systems can lead to more users leads to more revenue, that's a direct goal that management can get on board with and help them to understand that an investment in secure code is an investment in good code and an investment in the bottom line. As we've covered a bit of how to collaborate and build checklists, there are also some anti-patterns that we should be aware of so that we can avoid specific problematic areas as we collaborate with the development teams to build these checklists. One of the most significant anti-patterns is length. Checklists have to be efficient, not comprehensive. This is where it helps to have a good understanding of your systems and your major vulnerability categories. You must be ruthless in your process to ensure that only highly relevant, highly probable, and highly impactful items are on your checklists. This also helps increase the relevancy of them and therefore the adaptability and use of them. Your checklists need to be simple. Complexity and ambiguity are counterproductive. Every item on your checklist should be easy to understand. The steps to complete that item must be clear-cut and well-defined. Finally, your checklists have to be relevant. If you give a developer a laundry list of terminology that they don't work with every day, that's a recipe for trouble. Items that are meaningful will get attention. Items that are considered irrelevant will get overlooked and minimized. So on to measurement. How do we measure our security output? How do we measure the effectiveness of our checklists? One proxy for this can be developer interaction and relationships with security. Having a process in place to collaborate early with your developers and to actually have some measurement of that over releases can give you numbers to drive your effective communication. So the more that you interact with the teams, the higher your scores can be. That's something that can be measured and used as a proxy for how interactive you're being with your development teams. Another measure can be security bugs that have been detected over time and in which phase they are detected. Catching something in design review is a lot more effective than catching something in code review versus having it shipped to production and having an external bug bounty participant report it to you. The earlier you can catch security vulnerabilities, and if you have the ability to track at which phase those security bugs are caught, is a really good additional proxy for the effectiveness of your security process and therefore the effectiveness of having these checklists in place. Here we have a few sample checklist items that have come from myself and from previous versions of this talk. You'll notice that this covers a variety of common development scenarios, common security vulnerabilities, and the checklist items themselves, the questions are concise. They are an attempt to be clear. They minimize the amount of security language in those questions and in the checklist items, and the answers are easy to tell what they are and what their completion steps are. This is some really good examples of how checklist items can look, how they can be effective, and how they can, again, serve as not a long-winded secure development process, but just as a quick and simple reminder to the developers as they're getting ready to commit their code or as they're writing their code, that have they encountered the scenario, and to remind them to do the right things security-wise about those particular pieces of code that they're writing. I have, of course, built a checklist in order to help us build checklists. This is, again, a list of 10 items that you need to keep in mind as you're building checklists. This is something that in our interactive session following this recording, we will use as our core criteria for collaborating on building relevant checklist items for some of our scenarios. And as with checklists, this does cover the most important things first. It does provide a clear and meaningful representation of what needs to be done. And it provides that satisfaction of having that checkbox of here is a clear, well-defined criteria and a definition of done for this particular item, so that we can then move down this list in order and come up with an effective and useful set of checklist criteria. Again, so in the collaborative session after this talk, anyone who's participating in that, we will collaboratively build checklist items that are relevant to our particular environments. If you have any feedback that you haven't already put in the chat, now would be a great time. I'm happy to answer any questions that may come up. We'll have a little bit of extra time at the end of this session. And finally, the references slide. Please feel free, take this back to your companies, build a process that works for you, for your organization, for your development teams. Collaboration is the key to this. Iterative development is highly important, something that you get out there, can test, and then build on is the preferred mechanism. Just building something once, throwing it out there and saying, this is the way we're going to do it forever and ever, is not going to be very adaptable. It's not going to be very flexible. So again, have those collaboration conversations with your development teams, with your other teams within your organization. Include management in this, get that buy-in, and get yourself a good, simple, straightforward process to remind those developers of all that expensive security training they've got at the point in time when they're writing code. With that, I want to thank you for your time today. I appreciate the opportunity to speak to you. Happy to continue this conversation in chat. Happy to continue this after the fact, as well as you can reach out to me on Twitter at any time. Thank you so much, and have a good rest of your RSA.